Hey guys, so I figured some of you might be a little confused about the reading assignment, and so I went ahead and decided to just go and do some videos of me doing some of the homework problems so that you felt a little bit more confident. Just to quickly review, there's only a couple of main things you really need for the homework, and that is you need to know the formula for a t distribution, and you need to be able to find the population size or the mean size. Or actually, that's not until later. But you need to be able to calculate, the things that calculate the intervals when your standard deviation is not known, or when your standard deviation is from the sample as opposed to the population. So to make sure that we remember what to do, all right, the formula is going to be the mean plus or minus the t sub alpha over 2 score times the standard deviation divided by the square root of the sample size. All right, so as long as you have this formula, you should be good. The only other thing is that you have to be able to use your t table, which you should have gotten from the teacher, and if you don't have it, you can get it in your book on page 781. It's right after the z-scores. All right, so now that we have our formula that we need to use, we can go ahead and we can figure out what items we have. So if we read the question, number 5, this is from your homework, and you don't actually have to do this problem, you have to do a different problem, but this is similar. It says a random sample of 15 registered nurses, okay, so we have a sample, so I'm going to write n equals 15, in a large hospital showed that they worked on an average 44.2 hours per week. So their average was 44.2 hours per week. With a standard deviation of the sample, okay, so since it's the sample, not the population, I'm going to put S. And then it says to estimate the mean of the population with a 90% confidence, okay? Now remember, this 90% is not the memorized ones that we had with the z-scores. This is with your t-scores, okay? And so because of that, we have to go to our sheet and sort of look at it, and what you need for that is to know what are the degrees of freedom. And the degrees of freedom, all that you need to do to get that is just use your your sample size and subtract 1. So my degrees of freedom, I'll write that right here, my degrees of freedom is 14, and I need to know the percentage of everything, which is my confidence level needs to be 90%. So I'm just going to go ahead and look at that really fast. So here is my t table, and it looks a little bit different than y'all's because of I got this from the internet. I didn't get it from the book. And I am looking for my degrees of freedom. I already said that my degrees of freedom is going to be 14. So here's 14 right here when I highlighted it. And I need to be 90% sure of my information. And so I go to my 90% down here, and I find the value that corresponds with that, which would be 1.761. So I'm just going to carry that 1.761 over here, 1.761, and now I have all the pieces that I need to plug into our formula. And so this should be 44.2 plus or minus 1.761 times our standard deviation, which is 2.6, over the square root of 15. I can use my calculator to type all of that in, and it should equal 43.02 between that and 45.38. And then this becomes my answer. So it's the same process as 7-1. It's just now you have to use a different formula because you don't know what your standard deviation is. So what do you do if you unfortunately do not have your mean expressly stated? Well, you can still find the information that you need. The thing is, you'll just need a calculator, specifically the ones that we're using in class, although I guess you could use any of them. But the first thing that we can do is just read the question and make sure that we understand and have all the pieces that we need. Number 7 says a state representative wishes to estimate the mean number of women representatives per state legislator. A random sample of 17, okay, so that's going to be my sample, is selected, and the number of women representatives is shown. And so that's this data down here. Based on the sample, what is the point estimate of the mean? So really they're just asking, what is the mean, okay? I did mention that previously, that the point estimate is like a fancy way of saying what's the mean. Find the 90% confidence interval of the mean population. And that's the same thing that we had in the last problem. So really we can just go ahead and put that T sub alpha over 2 is equivalent to 1.761. That was from the last problem. All right, so now what I'm going to do is I'm going to go ahead and I'm just going to enter in all of my numbers into my calculator. So it'll take a couple of seconds, but if I plug it into my calculator, then it can do all the work for me. So here's our calculator for our classroom, and I'm going to go ahead and enter in all my information in the statistics category, which is this button right here. And I'm going to go to number 1 for edit, and I'm going to enter in all these numbers. So give me a second. So I went ahead and entered all of my numbers. I don't have to order them or organize them in any way. And I can do a quick count and see that I have 17 numbers. And if you notice, my highlighted last one that's asking me to enter in more information is number 18. So I don't know if I have the right numbers. I can just sort of look over that and make sure I didn't make any mistakes. But I can tell that I at least have the right number of values. So I do look at I see on my screen, I actually have a sort of typo, at least it might be a typo. I see it says 132, 35, and then 4. So I'm gonna check my list, and I did make a mistake. It should not be 4, it should be 45. So I'm just gonna go up there and fix that really fast. And I don't really see any other mistakes. So I'm just gonna go ahead and click my next button, which is to go back into statistics and go to calculate. So I use my arrow, and I want to press number 1. It wants to ask if I want the list that I enter all the information into. Yes. And now I have all the information I need. I have my mean, which is at the very, very top, and you can see it right here. And the other thing that I need is my standard deviation, which is annotated by S. And remember, you got to use S this time because we're talking about the population, or about the sample. We're not talking about the population because we don't know what the population is. They do give you an estimate of what the population will be below the S, but you do not want to use that. It's going to throw off your numbers. So let's jot down that information and then go back to our problem. All right, so from our calculator, we were able to figure out that our mean is going to equal 33.35, and then our standard deviation was 28.69. I just went ahead and rounded to 2 decimal places. And actually, I realized that I made a mistake. When we are working with the z-scores, our 90%, 95, and 99% are consistent. But when we are working with our t-scores, they change every time. So previously I said that this is the same as the last problem because it's the same percentage, but in fact that's actually incorrect. And the reason why is because our degrees of freedom have changed. Our degrees of freedom are always going to be 1 less than our sample size. So my new degree of freedom is 16, and the last problem was actually 14. So I made a mistake. I'm going to have to go back and look at my table to see which one is in fact my t-score. So I'm going to go ahead and just erase this, and then we're going to go back to our table. So here's our table. We said our degrees of freedom this time is going to be 16. So I have that 16, and I still want 90% confidence level. So when I find the 16 with a 90% value, it's going to be this value right here, 1.746. All right, so our value is 1.746. And now I can go ahead and work all of this information out. So I'm going to take this, I'm going to change the color really fast so I can plug it in. 33.35 is our point estimator of the mean, and we'll say plus or minus our t sub alpha over 2, which is 1.746, we fix that, times our standard deviation of the sample, 28.69, over the square root of our sample size, which is 17. Take a calculator, plug it in, and figure out what our answer is. If you do it correctly, it should be 21.20 and 45.5. And that is our final answer. All right, just wanted to make sure we're still understanding what to do, so I'm going to do this one rather quickly. A sample of 8 elephants had an average of 12,300 pounds, so my sample size is 8. That means my degrees of freedom is going to be 7, so I'm going to use that in a minute. And the average weight is going to be 12,300. The standard deviation of the sample is 22 pounds. And I need a 95% confidence interval. So I remember you need to use your degrees of freedom for that interval, and you need to use the table as well. So we have our t sub alpha over 2, and we're going to quickly just jump over to that table. So here's the table, and we had a degree of freedom of 7, so here is our degree of freedom of 7 right there. And we are just going to go over to the 95% confidence level. So I'm going to come over this way, and it is here. 2.365 is going to be our t value. All right, so let's put that on our paper. Okay, 2.365. And now that I have all my pieces that I need, I can plug it into my formula. Again, the formula is the mean plus or minus t sub alpha over 2 times s over the square root of n. Plug in all of my pieces. And calculate it. And since we have such large numbers already, I'm going to go ahead and just round it to a whole number, just to make my life a little bit easier. And so we should get 12,281 and 12,318. And that is our answer. All right, so here's the last problem that we're going to do. It's very, very similar to problem number 7, and it says the approximate cost for a 30-second randomly selected spot for various cable networks in a random selection, typo, of cities is shown. So here's all of my data that I'm going to be using in a second. Estimate the true population mean cost for the 30-second advertisement on cable network with a 90% confidence, okay? So I can quickly count all of my values here, and I can see that I have a total of 17 values of information. That means my degrees of freedom is going to be 16, and I need a 90% interval for my t sub alpha over 2. And I need to use the calculator to figure out what is my mean and what is my standard deviation. So I'll do the easier of the two first. I'm going to go ahead and find my t-score. So we can go back to this table, and we have a degree of freedom of 16, which is going to be this value down here. Oops, wrong one. So here's the 16, and I need a 90% confidence value, which is going to be 1.746. So I'll write that on our paper right here, which is 1.746. All right, and then I'm going to go to the calculator and plug in all of my values there as well. So here we actually have this information from the last problem, so I'm going to go ahead and clear that out and go back into stat and to 1, and unfortunately have all of these values still. So what I'm going to do is I'm just going to clear it out by going back into stat, and number 4 says to clear the list. So I'm going to do that, and then I need to tell it to do the list 1. So I'm going to go to second, and then number 1, and press enter, and it says done. So now if I go back into the list, everything's gone. And so I'm going to enter in these values. All right, so I entered in everything. I counted that I had 17 values, and I landed on number 18, so I know that I have 17 values already. I can do a quick little scan just to make sure that I have all the correct numbers. 9 seems really, really small, so I'll double check it. Yep, that one's fine. And 165 is also really big, but it's also fine. So now that I'm done with that, I can go back into the statistic button, go over to the calculating, and I want to press number 1 for various statistics. Press enter until you get to your information, and now all of our information is here. So we have 51.47 as our mean, and our standard deviation for the sample is 45.98. So I'm going to take those numbers, write them down on my paper that we just had. All right, so that was 51.47 and 45.98. Now I'm going to plug it into the formula. This is going to say 51.47 plus or minus our 1.746 times 45.98 over the square root of 17. We can now plug this into our calculator, and we are going to get 31.9 something, and it ends up rounding to 32. And since the first one rounds to a whole number, I'm going to actually do the same thing with my other one. It should be 70.94, but I'm just going to round it up to 71. So it's similar to my first problem, or my first number, I should say. And so that is the examples that I wanted to do for you guys. I hope that helps you with your homework, and please make sure you finish it and turn it into the sub.